Hey, Dr. Walker, we're doing the tutorial one electric field tutorial problem. In the diagram, Q1 is equal to 50 microcoulomb and Q2 is equal to negative 20 microcoulomb. Q3 is 30 microcoulomb, and choose different lengths for A, B, C, and D in centimeters and find the electric field at point P. We went ahead and chose our A to be 10 centimeters, our B to be 15 centimeters, our C to be 7 centimeters, and our D to be 12 centimeters. After that, we decided on our equations. We decided on E equals KQ over R squared. This shows our potential difference equation at 2 points. So we went ahead and made our XY chart. We did Q1 is.
Keep going, Habibi.
No,
It's
I
fine.
need the chart. What is its name? Potential difference? It's not between 2 points. What is it? So our equation for E equals KQ over R squared was for the electric field due to a point charge. We use this equation by
So this point
turning
P,
these
this
three
point.
back into microcoulombs, and that turns it into what we have down here. Q1 is equal to 0.00005
Just coulombs.
times our constant, which was 8.99 times 10 to the 9th, over our distance in meters, which is 10 centimeters, is 0.1 meter squared. We end up getting our 4.495 times 10 to the 7th, n divided by coulombs or whatever. What is it called? You get rid of that?
Newton per coulomb. Keep going.
Newton per coulomb. And then we also ended up doing it for Q2 as well. Q2 was a little different because we had a line going towards Q2 since it's a negative, and Q1 and 3 are positives. We had Q1 as the 0.00050 coulombs times 8.99 times, or I'm sorry, negative 0.00020 coulombs times our constant, which is 8.99 times 10 to the 9th, divided by our 0.156 squared, and you get negative 7.4 times 10 to the 6th. We got our 0.156 by doing the hypotenuse. So 15 squared plus 7 squared, the square root of those gets our hypotenuse, and that ended up getting our 0.156 meters. And then that's how we also get our magnitude, which is negative 7.4 times 10 to the 6 newtons per coulombs. And then we ended up going to Q3. Q3, same exact thing. We did our 0.00030 coulombs times 8.99 times 10 to the 9th divided by 0.15 squared, which is again our range. And we ended up getting our 1.2 times 10 to the 7th. Now, if you see in our image, we can see Q3 is objecting into the right direction on the x-axis of P. Q1 is going on the y-axis, and Q2 is pulling in the diagonal axis. That means that we know Q3 is our x, we know Q1 is a y. So that's helpful for our next steps. Our next step is to write out our x and y factors.
Components.
Yeah, Q1x is 0. As we can see, it goes straight down and it only has a y-axis. That means we know our y is the same as our magnitude, which we found, which was 4.495 times 10 to the 7th. We have Q2x and Q3y. These, it gets a little bit tricky because you have to find the angle. And to find the angle, we went ahead and came down here. We had our magnitude and drew a little triangle for ourselves off of P. And with this, you can simply, you pause it. How did we do that?
Okay.
And to find our angle, we went ahead and did our C over D sides. So we did tangent, inverse tangent of 0.07 meters over 0.12 meters. This gets us an angle of 30.256 degrees. This is the degrees we can use to find our Q2 points for the x and the y axis. To do so, we went ahead and used our magnitude, which we already know, negative 7.4 times 10 to the 6th, cosine 30.3 degrees, which we discovered. And this gets us a negative 6.4 times 10 to the 6th x, as it is going in the left direction. Now to find our y, we know it's going upward, so it has to be positive. This means we did the same thing, except we used sine. So negative 7.4 times 10 to the 6th sine of 30.3. We have to make this positive because we know it's going upwards. So we get 3.7 times 10 to the 6th. This gives us our x and our y for Q2 and Q2x and Q2y. And then we move on to Q3. All right. And we have our Q2y and Q2x, which we just found out. And now we're looking for. You good?
Yeah.
And then we find our Q3x. We know Q3 only has an x, which we already found earlier. That is when we refer back to our equation, E equals KQ over R squared. We found Q3 over there. We got our 1.2 times 10 to the 7th. That is positive x going to the right. We know that we have, for our y, we have 0, considering it is just an x-axis going along the horizontal. After we have all those points, we can find our rx and ry. Those are sort of our averages, and we can take those and find the hypotenuse of the r. Rx, after adding all these points together, you get 5.6 times 10 to the 6th, and for Ry, you get 4.9 times 10 to the 7th after adding all these points together. To find your R, which is technically sort of your line of best fit, you want to go ahead and do the square root of those two added to each other, and you're squaring both of them, so it's 5.6 times 10 to the 6th squared plus 4.9 times 10 to the 7th squared. After doing the square root of both of them, you get an R for a 4.9 times 10 to the 7th. After doing so, that is officially your magnitude of the electric field on your point P, and that is sort of our answer we're looking for. Now we want to find direction. To find direction, you want to do the inverse tangent of y over x. Our y in this scenario was 4.9 times 10 to the 7th. Our x was 5.6 times 10 to the 6th. After doing that, you get 83.5 degrees, and then you ask yourself, which direction is this facing? Well, when you go ahead and do the tip-to-tail method, which we learned about in class, you can see that the R is going north of east. So that's how you would end up doing your equation. It would actually be negative 83.5 degrees north of east.